This is a radio frequency remote controlled car. This is the remote, and in this car, this is the receiver, this is the latch circuit, and this is 12-volt battery. These are two relays, and I have used 4 gear motors, 100 rpm each. This is receiver module, and this part is transmitter module. If you push this button once, the car will move towards right like this. If you again push this button, it will stop. If you push this button, the car will move towards left like this. And pressing again, it will stop. If you push both the buttons, the car will move towards me, that means like that. And if you push them again, the car will stop. Here we have used a 7805 voltage regulator IC to get 5-volt DC supply from a 12-volt battery. This is pin number 1, this is pin number 2, and this is pin number 3. The final output is taken from pin number 3. The input is given to pin number 1, and pin number 2 is grounded. A 0.1 microfarad mica capacitor is used across the final output for better stability. We have used here HT12D. It's a decoder IC, and it has 18 pins, and this is HT12E. It's an encoder IC having 18 pins. Both these ICs are used as a pair. This will encode the data, and this will decode the data. We can get 8 address bits and 4 data bits by using this decoder IC. When serial data is given as input to the decoder IC, it converts it to parallel data, that means 12-bit parallel data. This 12-bit parallel data is divided into 8 address bits and 4 data bits. The encoder IC encodes the 12-bit parallel data into serial data for transmission through an RF transmitter, and these 12 bits are divided into 8 address bits and 4 data bits. Encoder IC is used in RF transmitter circuit. Decoder IC is used in radio frequency receiver circuit. The encoder IC and decoder IC are tested first before using them in the transmitter and receiver section. In this schematic, we have to test the encoder and decoder IC. The pin number 17 of encoder IC, which is D out, is connected through a wire with pin number 14 of decoder IC, and the pin number 14 of decoder IC is D in. That means D out of encoder is connected with D in of decoder. There are 4 LEDs with 4 pull down registers in pin number 10, 11, 12 and 13 of the decoder IC. There are 4 push buttons which are connected in between pin number 10 and ground, pin number 11 and ground, pin number 12 and ground, and pin number 13 and ground of the encoder IC. Initially, all LEDs are in glowing states. When you push the button corresponding to pin number 10, at that time only the LED connected to pin number 10 of decoder IC is off, and at that time the rest 3 LEDs are still glowing. And like that, when you press the button corresponding to pin number 13 of encoder IC, then the LED corresponding to pin number 13 of the decoder IC will be off, but the rest 3 LEDs are still glowing. This schematic represents the receiver and this schematic represents the transmitter. Both the transmitter and receiver are operating in 434 MHz frequency. The transmitter and receiver module are based on phase locked loop control system, and the transmitter contains a surface acoustic wave oscillator. We are operating them with 5-volt DC supply. This is the schematic for transmitter section. This is the encoder IC. These are 4 push buttons. This is the transmitter module, and I am getting 5-volt from a 9-volt battery by using 7805 voltage regulator IC. And this is the antenna, and it is a hat type copper wire. This is the schematic for receiver section. This is the decoder IC. This is the receiver module, and this is the antenna. So after making the transmitter section and receiver section, how to avoid interference with your friends who are making the same project and testing it simultaneously. First thing is the address pin connection patterns of encoder and decoder should be identical for a student, but it must not match with any other students. If this happens, your receiver will respond to your friend's remote and vice versa. Here we have grounded all 8 address pins of encoder and decoder. You can select any combinations of address pins to be grounded. For example, you can take both pin number 1 and 2 to be grounded of encoder, as well as both pin number 1 and 2 to be grounded of the decoder IC. So you can choose any combinations according to your choice, but the encoder circuit and decoder circuit should be of identical patterns when you are grounding their address pins. To prepare a latch circuit, we are using a 4017 IC, which is a decade counter. For every advancement of clock pulse, it counts from output 0 to output 9. That means it has 10 outputs, but the outputs are not in order. That means we are getting the initial output 0 from pin number 3, output 1 from pin number 2, output 3 from pin number 7, output 4 from pin number 10. That means the outputs are not in order. This is the schematic of a latch circuit. I have used only 2 latch circuits here to operate the RF car. If you want, you can use 4 latch circuits by using this schematic. To get the trigger signal, you can connect this point directly with the pin number 10 of the decoder IC, and in this way there are 3 more pins, pin number 11, pin number 12 and pin number 13. You can connect the 3 pins with 3 individual latch circuits. If you want to learn the operation of latch circuit, visit the website given in the description box. I have described it in the detailed form.